Welcome back. In this video, we are going to talk about vector notation. We're also going to touch upon different kind of vectors, and specifically we will be looking unit vectors in detail. Okay, so let's talk about vector notation. So let's consider a point O and point P just connected by a line with the direction. So what we call this as OP with the arrow sign which represents vector. So this is OP vector. So any vector would have an origin, a terminal point, and a direction. So this is OP vector with direction O to P and magnitude equals to length of OP. So we have defined OP vector. Let's see how we define the magnitude. So OP vector is defined as mod of OP vector. Now suppose if we give the name to this vector, which is A, then we will say OP vector is equals to A vector and length of OP vector is equals to A. So hence any vector would have an origin, a terminal point, the direction, and the length. The vector is represented by its origin and terminal point with an arrow, or it could be given as name as A vector. Magnitude is defined as mod of the vector, or simply the length of that defined as A in this case. Kind of vectors. So let's say if you have point O, point P, and vector A with the length of an OP is equals to A. What if point P, point O, and point P is same? That will implies mod of OP vector equals to 0, right? That is, the magnitude of the vector is 0. Such vectors are called null vectors or zero vectors. In principle, any point is basically null vector, and it's very difficult to define the direction of the null vector. However, the concept has been defined in mathematics, so we call it null vector or zero vector. It is represented by 0 with an arrow on top of it. Now let's talk about a more important concept, which is unit vectors. So if you have an OP vector, then unit vector is nothing but a vector with magnitude equals to 1. So unit vector in direction of OP is defined as OP hat. So you will see a notation to define unit vectors by an hat is the vector itself divided by the length of the vector. Okay. So if you have a vector AB with length 5, then unit vector in direction of AB is equals to an AB vector divided by 5, that is the length of AB vector. Right. Now we'll see why this concept is so important, right? So in order to define the importance of concept, let's first think about a plane. So in your coordinate systems, you would have seen a two-dimensional plane can be represented by an x-axis and y-axis, and at any point P can be defined as its value at x and the value at y. Say this is 3, this is 4, 3, 4. So this length OP, this is O, and say this is a vector. The length OP vector is nothing but 3 square plus 4 square, which is a Pythagoras theorem, which is 25. So OP vector is equals to 5, right? So we can say OP vector is basically the unit vector is nothing but OP vector divided by 5. Now, why is an important concept? So the way we defined the unit vector in the direction of OP, we could define a unit vector in the direction of x and a unit vector in the direction of y. And similarly, if we, so there's a special name to them, which is I hat and j hat. And if we know the unit vector in the direction of x and y, we can represent OP vector as how much we are in direction of x, which is 3, right here, in direction of x with its unit vector, plus the magnitude in direction of y, unit vector along y direction. This is a standard or a coordinate way of representing vector in two-dimensional space with known x and y component. Right? And therefore, OP hat, which is basically a unit vector in direction of P, is nothing but 3 by 5 I hat plus 4 by 5 j. We also saw an important concept that the magnitude of an OP vector is nothing but 3 square plus 4 square. So what does that signify? This signifies that OP vector is represented by A1 I cap, that is a magnitude of A1 towards the x direction plus magnitude of A2 towards y direction. Then the magnitude of a vector can simply be a square root of A1 square plus A2 square. Right? So now if you know the coordinate systems and you know the value in the x direction and y direction, which is given by magnitude and with an I cap and magnitude of A2 multiplied by j cap, then we can simply say that the value of magnitude of an OP is A1 square plus A2 square. Right, this is in two-dimensional space. Now let's move it into three-dimensional space. Okay, let's think about three-dimensional space. So you have X, you have Y, and you have Z. You define a unit vector I hat, a unit vector J hat, and a unit vector K hat. Right? So I hat magnitude equals to magnitude to K hat magnitude equals to 1. However, I hat direction is not equals to direction J hat is not equals to direction K hat, which means that I, J and K are equal in magnitude, but they are not equal vectors. So now if you have any vector P, let's take a different pen, which is an X component, Y component, and Z component, and we can define OP vector as magnitude in X direction multiplied by I hat, magnitude in Y direction multiplied by Z hat, is magnitude in Z direction multiplied by K hat, and we can say OP vector magnitude is nothing but 3 square plus 4 square plus 5 square, which is 25 equal, and therefore unit vector in direction of OP is OP vector divided by 25 equal. So this concept of unit vectors, specifically in the coordinate systems, would be very useful in solving all of the questions that we're going to do, all the computations that we're going to do involving vectors, and specifically there's also important concepts which you will see a lot in physics while defining the directions. Let's quickly touch upon some other concepts. Equal vectors, or vectors with same length and same direction. So OP vector is equals to AB vector only if OP vector is equals to AB vector in direction of OP vector to direction of AB vector. So initial vectors, so vectors which have same origin are called co-initial vectors. Other concept that will run is free vectors and localized vectors. Let's clear some space and then talk about these two concepts. Free vectors. Vectors, when transformed into space from one point to another point, does not change its magnitude or change its directions, are called free vectors. So for example, if you have a vector OP, so displacement of 5 km north, if you move this at this point, say again 5 km north, so there is another concept called localized vectors. So what does that mean? So localized vectors may be in the same direction and have the same magnitude, but the impact of that vector on any physical quantity is different. So let's take an example. You have, say, a mass m, you apply a force F. You apply the same force F at the top of this mass, right? Now F1 is equals to F, as it has the same magnitude and the same direction. However, the impact of this vector is different. F will move mass forward, whereas F1 will give a force called torque, so we'll try to topple this mass down, right? Try to rotate this mass. So it's the same vector from a mathematical perspective, so it has same direction and same magnitude, but the impact of that vector is different on a physical quantity. Such vectors are called localized vectors. In mathematics, we will only deal with free vectors. So in mathematics, we will deal with free vectors. You will see a lot of concepts of localized vectors when you will do physics questions. This concludes our chapter on kind of vectors.